So hello everyone, welcome back to LeetCode Daily. In this particular video, we are discussing LeetCode Weekly Contest 436 problem number B, and the problem is assign elements to group with their constraint. And the problem is, in this problem we have to given an integer array of groups, and where groups of I is represent the size of ith group, and you are also given an integer array of elements, and your task is to assign one element to each group based on their following rules. And we have to given three rules, and we have to return the assigned like integer array assigned, where assigned of I is the index of their element, and we have to choose in the group of I or -1 if no suitable elements exist. And then we have to given a note of here, like an element may be assigned to more than one group. Okay, and so now let's look at their problem statement. Then we have to look their example test cases and dry run their example test cases. And so in this example, first we have to given like here first we have to given a two array, like first is groups of I, and this groups of I is represent the ith group, and you you are also given an integer array of elements, and this elements like this elements of j, and this elements of j is contain the number that can be assigned to our groups, and these are our three conditions we have to given. And then we have their conditions to assign each group an element based on their following rules basically. And the first is we have their groups of I. This groups of I can be assigned an element of groups of j, sorry, elements of j, and this elements of j only if groups of I is divisible by elements of j. It means group of I is divisible by elements of j. Okay, and then uh, we have their second rule, and the rule is we have if the multiple elements satisfy. Okay, if the multiple elements satisfy this condition, we have to choose the element with the smallest index of j. Okay, we have to take care of this one also. We have to take only a smallest index of j if the multiple elements satisfy this condition. Okay, this condition. And now the third one is if no elements is satisfied, then we have to assign into a group is -1, and the output should be an array form of assigned of I, and this assigned of I is the index of the element which chosen for a group of I or -1 if no suitable elements are present on that condition. And now the first we have there given this divisible. This one second. This divisible means a number a is divisible by b. It means a mod b is equal to 0, and example is like 8 mod 4 is equal to 0, and this is our divisible. And the smallest index means if multiple elements can be assigned, we pick the one with the lowest index of element of I, this element of I. And after this, like you can say element, let's suppose we have 4, 2, and the both here both 4 and 2 can be assigned. We can take that the first occurrence. Okay, only first occurrence we have to take. And now let's dry run their example of first test case so that you can understand how actually we have to work on their like groups and their elements. And here first we have their values, like uh, here we have their group, and this group is 8, 4, 3, 2, and 4, and the elements we have to given 4, 2, and the possible elements we have to divisible by, like how many elements, like first we have to calculate their divisors, and these divisors like 8 divisors are 1, 2, 4 and 8, and 4 divisors are 1, 2, 4, and this 3 divisible are 1, 3, and this 2 is 1, 2, and this 4 is 1, 2 and 4, 1, 2 and 4. And now we have their valid elements of here valid element, and this valid elements of j. Okay, here we have to calculate with j, and this index of 2, sorry, this 2 with index of 1. Okay, we have to assign only this 2 index of 1 and this 4 index of 0, and here we have to calculate the values, like smallest index we have to calculate. And first we have there 1, 2, 4, 8, and this 1, 2, 4, 8 we have to calculate each and every value, like we have to assign a of 4 is equal to 0. Okay, and a of 2 is assigned for 1. Okay, this is our assigning condition, like smallest index where 4 appears, like at this position and this position, you can say, like you can assign all values with any position. Okay, and now we have to calculate with their group of this group of 0, and this group of 0 we have there here 1, 2, 4 and 8. Now we have to find their divisors. This is our divisors, and this divisors we have to calculate their valid elements. How we can calculate this one? First we have to take this one, and this one we have no element, like this one is present all values, like this one is always a divisor by all values. Okay, so we cannot take this one, and now we have to move this 2, and this 2 we have there 4 mod 2 is equal to 0. It is our index of 1. Okay, and then uh, this 4, and this 4 is 4 mod 4 is equal to 0, and this is our index of 0. We already define here, like if 2 is present then index 1, and this 4 is present and then index of 0. And now we have to take the smallest index, like which was our smallest index. This is our smallest index of I is equal to 0. So now what we have to get, here is 0. And now in second iteration we have their group of 1, this group of 1, and this group of 1 we have there 1, 2 and 4. Okay, and then we already said that, like 1 is already discarded here, like this is useless, you can say. And this 4 mod 2 is equal to 0, and this 4 mod 2 is equal to 0, it means index of 1. And this and the second one is one second 1, 2, 4, and this, yeah, okay, and this 4 mod 4 is equal to 0, and this is our index of 0. It means we have to mod with this value, like 4 mod, like you can say, sorry, here 8 mod 2, here 8 mod 2. Okay, and here we have to uh, group of I mod with their divisible of all elements. Okay, and now we have to calculate it here, like 4 mod 2 is equal to 0, and 4 mod 4 is equal to 0, and this is our index of 0. Okay, and this is our index of 1. And now which was the minimum of both values index. This is our minimum, so here assigned with 0. And now this 3 and this 3 we have their values, like this is not an element on our like one already discarded here, and then this 3 and this 3 we have no any values, like we have only 4 comma 2 given here. Okay, and this 4 comma 2 we only check with their 4 and 2 values. But if any other values like 3, 5, 7, 9 and so on, these type of values are occur, then we have not track any values, like. Okay, so we already discussed here, like if there is no any group, then we have there -1, and this one assigned with -1 because no valid elements are found here. And then in next iteration we have there a 2, and this 2 with mod with their 2, and this 2 mod 2 is equal to 0, which is our index of 1, so it is 1. And now this 4, and this 4 mod 2 and 4 mod 4, and this 4 okay, this 4 mod 2 is equal to 0, and this is 1, and sorry, this is 1 and this is 0, and the minimum of the both values are 1. So this is, sorry, this is 0 and here is 0. And now what we have to get, we have to store into our array form. And now what we have to get, 0 0 minus 1 1 and 0, 0 0 minus 1 1 and 0. So I hope you understand. We have to track with, like, in simple terms, what we have to do. First we have to take their group, and each group we have to calculate their divisors, and these are our divisors and these are our groups. Okay, and after group we have to calculate this condition, like group of I mod their divisor of j, you can say. Like each condition we have to calculate each value, like this one, this one, this one, this one, and we have to not track with this one, because if we have to calculate with their mod of 8 mod 1 is equal to 8, so we have to get the previous value we have to already present. So then we have not take any one of each divisor, so then we have to track another elements, like here 2 4 8, and here 2 4, here 3, and here 2, and here 2 and 4. And one condition we have to take care of, this one we have only given 4 and 2 elements, and only we have to perform the operation only if 2 and 4 is present, and if there is no any values are present on their divisors, then we have written -1. Okay, here on, then we have to return -1, you can, yeah. So I hope you understand this example, like how actually we have to iterate their valid conditions and how we have to find their divisors and of each position. Okay, and now let's look at their example, this one. Okay, and this example we have their group of 10 21 30 and 41, and the elements we have to given 2 comma 1. And now we have their group of I. First we have their group of I, and the group of I is 10 21 30 and 41, and the divisors, and these divisors are 10 divisors are like 1 2 5 and 10, and this 21 is 1 3 7 and 21, and this 30 is 1 2 3 5 6 10 and 15 and 30, and this 41 is 1 comma 41. And now after this we have the values is like we have their elements is 2 comma 1. Okay, 2 comma 1. Now we have to calculate the same values like before. This 2 we have their index value is 0, and this one index value is 1. Okay, and now we have to calculate with each position. First we have their divisor of 10 mod 2 and 10 mod you can say, yeah, only 10 mod 2, because we have to given 2 and 1, and this 1 and 2. And so now this 10 mod 1 is equal to 10, and this 10 mod 2 is, we have to get 0. And now we have their minimum, and the minimum of 0 we have to assign with their value is 0. And now the next iteration we have their 1 3 7 and 21. Okay, and then what we have to get, we have to get first we have to get, like, this is our index of 0 and this is our index of 1. Okay, and now here 21, and elements is we have to get given here is 2 comma 1. And now you have to take care of 2 is our index of 0 and 1 is our index of 1. Okay, this is our index. And now 21 mod 2 and 21 mod 1, and this become 21 and this become 21. And now what is the minimum of, like, one second, 2 is not given here, sorry. So only one minimum is here. So which index? Only one index, this one. So we have to assign with 1. Okay, and then we have their next iteration. We have their 1 2 3 5 6 10 15 and 30, and this 30 mod 2 and this 30 mod 1, and this 30 mod 2 is what we have to get 0, and this 30 mod 1 is 30, and the minimum of all both values is this one. After mod with 2, then what we have to get, we have their index value of 0, and then we have to assign with their 0 value. And now here we have their 41, and 41 mod 1 is equal to 41. This is only one minimum here, so then we have to assign with their value with 1. And now the answer is 0 1 0 and 1, 0 1 0 1. So I hope you understand the dry run example. Like, first we have to assign their index values, like 2 comma 1. Okay, let's suppose 2 comma 1, this is our index of 0 and this is our index of 1, and now we have to mod with their divisors. Okay, so the key observation is, first we have our groups, and the groups are assigned to their smallest index, and after we have to calculate their divisors, and then if no elements can be divided by their group, we have to assign with their -1. And after this, okay, and after this we have even numbers of 10 to be assigned with 2. Okay, 2, and odd number assigned with their 1. And we efficiently check with their divisibility using square root, and we have to decompose their values, and we have to keep track their optimal solution. Okay, and now let's look at their constraint basically. So the constraint we have to given here 10 to the power 5, 10 to the power 5, 10 to the power 5, and 10 to the power 5. And so basically we have their one too large number of this one. Okay, 10 to the power 5. And now we have to track with their values, and like we have their calculate all values by using feasible solution. Okay, so now let's look at their coding implementation part, so that you can understand how we find their divisors, and after divisors we have to calculate their values of each position. Okay, and this is the simple code. And basically here this is our first step, sorry, yeah, this is our first step 1. And one second, and this one is our step 2, and now this is our step 3. Okay, and after this we have to check all the values. Okay, so now first first this one, this vector of int a of n plus 1 comma m, and this answer is n comma -1. So basically this will store the smallest index of each element, store element of each index. Okay, and then step 1 is basically to find the minimum. Okay, so basically we have to store the smallest index for each element. Here we have to store the each element of each index, we have to calculate their minimum index, and then we have to process each group. Okay, each group means first we have to calculate, let's suppose group 0, group 1, group 2, group 3, and so on. Okay, and after this we have their values, and first we have to initialize with their large value we have already given 10 to the power 5. Okay, then we have to track with their +5 values, like we cannot getting any TLE and runtime error, so that's why we have to 10 to the power 5 plus 5. And then here we have to assign initialize with their large value. Okay, And then this step 3 means we have to check their divisors using square root. Okay, here we have to calculate the square root and then we have to decompose, okay, all the values. And then if that group of I is mod with j is equal to 0, it means j is our divisor. And then we have to calculate, we have to check their first divisor. Here we have to calculate their first divisor, and then if we get the first divisor, then we have to second divisor we have to calculate here. Okay, and after this we have to calculate the minimum index, like which one will be minimum. Like you have to groups like 2, 4 and 3, and we have to mod with their values, like mod with their group of I. And if group of I is uh, let's suppose here is minimum, then we have to return this one. Okay, so this is the simple example we have to assume. Okay, and then we have, here we have to store all the values with a answer, and you can say result. And then if the temp is equal to m, it means we have to iterate all values with their temp values. Okay, here temp values. Then if the temp is equal to m with the large value, uh, it is true, then we have to return -1, else we have to return minimum index. It means we have to get our value. Okay, then we have to return -1, sorry, answer. So I hope you understand this simple code. Basically what we have to do, we have to check with their each and every position, like we have to update our j, and then we have to check with their group of I mod j is equal to 0, and then we have to perform the simple two condition, like if a of j not is equal to m, then we have to calculate the minimum index. Okay, and if not getting our first minimum index, then we have to iterate our second minimum index. And now I hope you understand the logic behind this code and their implementation part. And now what we have to do, we have basically explore all the values, like assign all the values, and then we have to iterate all the values with each and every position. Okay, each and every position we have to iterate, and then this one. Okay, then we have to calculate with their divisors, and after divisor we have to calculate with their pre-process, like here 1, 2, 4 and 8. And after this we have to check with their groups and their elements. And if 4 and 2 only our element, then we have to check only 4 and 2. Okay, we do not take care of any other elements. Okay, so I hope you understand this coding implementation part. And so now let's look at their time complexity. And the time complexity of this code is we have to pre-process with their a. Okay, and the pre-processing is o of like you can say O of m time. Okay, and we have to check with their divisors with their groups, like here we have to check with their divisors with their groups, and it takes O of n into square root of 1 0 1. Yeah, okay. This times it means this simultaneously this work on O of n into 316. Okay, and now the total time complexity of this code is O of m plus n into square root of n. Okay, and so this is our time complexity. So space complexity of this code is we have their array of this this a, and this take O of n time, and this output array vector you can say O of n time. So that the total space complexity of this code is O of n plus n. Okay, so I hope you understand the logic and the implementation part. And so, and also their dry run their test cases, like we have to calculate with their divisors, and then we have to calculate with their index values, and then we have to get their smallest index, and then we have to set their values. Okay, so thank you everyone, thank you so much.